Hi, this is Brandon Lewis with Embedded Computing Design Magazine here at the 2015 Sensors Expo in Long Beach, California. Here with John Austin, Product Marketing Manager for Analog and Interface Products at Microchip Technology. And we have a sneak peek today at a product that's not been announced at the show, but is coming out later this month. Can you tell us a little bit about it?
Yeah, so the MCP 9600, it's an industry first. I mean, it integrates all the signal conditioning, the cold junction compensation, and everything required to convert a thermocouple EMF to a degree C reading over an I2C bus.
Okay. What are some of the problems this is solving for design engineers?
You know, the biggest problem with thermocouple designs is they're very complex. So the electromotive force, the voltage that needs to be read per degree C is in tens of microvolts. So it's very small. It requires precision instrumentation. It requires accurate temperature reference, or what you would call cold junction compensation. It requires precision data conversion. And then it's really complex math required to convert that thermocouple EMF to a degree C reading.
Okay. Well, there are more than one type of there's more than one type of thermocouple. Does this support one particular type, or?
No, actually, built into the firmware supports all the standard thermocouples, so K, J, T, N, S, E, B, and R. And those are basically all the standard thermocouples that you can find in the market today.
Okay, how is it able to do that?
It's just integrated, so we have all those equations built into the firmware. The math engine does the calculation, and the user can select via the I2C interface which thermocouple they're using.
Okay. Can we take a closer look?
Absolutely. So this is the MCP 9600 demo board. You can see the MCP 9600 right here. It's in a 5x5 QFN package. One thing to note is that there's no passive components. I mean, really the only thing on the board is the microcontroller and the 9600, and then you have a connector for the thermocouple. The board comes with a K-type thermocouple, so I'm going to go ahead and plug that in. And then if you look on the GUI, right here is where you would select the thermocouple type. K is selected, but it has all the other options available. If I want to do just a single update, I can click the Update Sample button, and it gives me a temperature reading over here in the registers. You can see the hot junction temperature, which would be the thermocouple. You can see the cold junction temperature, which would be the temp sensor on the device, the integrated temp sensor. And then it gives you the calculation of the hot junction minus the cold junction, so the delta between the two. And then it also gives you the measured value of the thermocouple in millivolts. So it gives you that value as well. And then the rest of the registers, like the status register, the sensor configuration, and the device configuration, really they relate to the different features that you can set up in the GUI. So for the demo, I'm not really going to go through those. But things to note is that you can set up the shutdown modes in here. We kind of talked about that during the presentation. You can set the resolution for both the hot junction and the cold junction, as those are, as I mentioned, programmable. And then you can also set up the filter in here under this tab. So up here in the upper left, there is a button that will allow the part to data log the temperature readings for both the hot and the cold junction. The hot is the red, and the cold junction is the blue, so the thermocouple is the red, and the internal temp sensor is the blue. So if I add heat to the thermocouple temperature, you can see it rising. And if I let it go, it should go back down. Excellent. And then down here in the bottom, you have all the features that we kind of discussed as far as the alert limits and things like that. So if I click on the binary register, you can see, I'll do alert 1 so you can see the change. But if you look at the alert 1, it's all zeros. If I enable, it turns it to 1. So I can enable all the different alert features. I can set the thermocouple or the cold junction as the reference temperature. And I can change the rising and the falling edge. I can select between the two. The rising edge corresponds to an over temperature condition, the falling edge under temperature condition. I can change the polarity from active high to active low, and I can change it from a comparator to an interrupt, and then I can set my limits and my temperature hysteresis down here on the bottom. And so that is basically the thermocouple demo board.
So where can we find more information, John?
You can find information at www.microchip.com/MCP9600.
Thanks. Thanks again. This is Brandon Lewis with Embedded Computing Design Magazine. If you'd like more information, go to www.embedded-computing.com for coverage on the show and other embedded news. Or follow us on Twitter at embedded_comp. Thanks.